Okay, hello guys, my name is Aluko Shayo Enoch. Welcome to my math tutorial on set theory. This tutorial will be divided into two sections. First, I will run through a board work on set theory, in which I'll be considering the following contents. One, defining set; two, union and intersection; and three, set relationship. And then the second stage, or can I say finally, I'll teach you a very wonderful and outstanding concept to describing region represented in Venn diagram using set notation. So we're going to take a look at how to use define the region represented based on this given set notation, or better still, how to describe the region represented here using vein using set notation. Okay, so let's get started with the first part of the tutorial, guys. Okay, so now set theory. So we're going to take a look at the following content: defining sets and defining set, guys. An intersection and then set relationship. So a set consists of objects or elements. So the elements can be numbers, letters, and so on. So elements are listed inside curly bracket, guys. So we use curly bracket in set theory. We don't use brace. Curly bracket is the same thing as brace bracket, guys. So we don't use this is what we call, this one here is square bracket. So you use square bracket in vectors, but for set you use curly bracket, so don't forget that. So let me just continue. So for example, you look at this is a set A, and with elements 1 to 9. So it's a set of single digit positive numbers. And you can see set B is a set of primary colors. Okay, so sets can be a finite or infinite number of elements, or they can be empty. So set with no elements, use brace bracket empty, like that, so nothing inside. So they are called empty set, or the null set, and are donated by null. Okay, or this. So you can use either of these to represent empty set, guys. So as well as listing all the elements, sets can be defined by describing them or algebraically. Okay, so algebraically, guys. So now, okay, I can represent set on number line. Okay, so when you have this open circle here, and this open circle, meaning that 0 and 5 is inclusive. But if this 0 is shaded, then it means that that's 1 to 5. And if 0 is shaded, 5 is shaded, then that will be 1 to 4. So now, since this is open set, okay, so x is such that the element of set lies between is from ranges from 0 to 5. So from 0, 1, 2, 3, 4, 5, like that. So that is set C. So C is the set of all elements. So x is such that 0 is less than x and x is less than 5. Okay, so this could also be written in this form, guys. Okay, but I need to make a clarification here, guys. Let me just quickly do this. Okay, so if this part here, this is shaded, if this part is shaded here 0, so this will be equals to, meaning that 0 is inclusive. So if this is closed, then that is from 0 then to 4, because 5 is not inclusive. But if this part here is shaded, okay, that will be from 0 to 5. Okay, so don't forget that. So let's go ahead with the presentation. So this means 3 is a member of, or 3 belongs to set of odd numbers. So this means belongs to, we use this to represent belongs to. So this means that 2 does not belongs to. Okay, so don't forget, 2 does not belong to set of odd numbers. So in a given scenario, there is a limit to the type of object that could be in set. So the universal set is the largest possible set for a given scenario. So for example, when we talk about even and odd numbers, the universal set is the natural numbers. So set of all natural numbers. So when needed in a problem, the universal set is normally given. So let's consider this content 2, and that is some union and intersection of sets. So the union of 2 or more sets contain all the elements in all the sets, and the union of set A and B is the element in either A or B, or both. So and the symbol we use for union is this like letter U, guys, like letter U. Okay, now let's consider the following sample problem. Now, given that A is outcome of rolling a die, okay, and B is positive integers between between an inclusive of 7 and 11. So we say between an inclusive of 7 and 11 means that from 7, 8, 9, 10, 11. So that's the implication. So we have to list the element A union B, A union B. So A union B means that we take some either element in either A or B or both. So let's take a look at this. So since A is 1 to 6 and B is 7 to 9, A is 1 to 6 because when you have a die, the faces show up. You can have 1, 2, 3, 4, 5, 6. Okay. So so the union will just be combination of this. So take 1, 2, 3, 4, 5, 6. Then you continue 7 to 11 like that. So that is the union of the two sets. So what about intersection of sets? The intersection of two or more sets contain the elements that are in all the sets. So for example, the element in both set A and B, and the symbol we use to represent intersection is this something like N. Guys, it's a Greek letter, not letter N. Okay. So let's take a look at the example. So A is outcome of rolling a die, and B is positive integers between an inclusive 4 and 9. So we have to list the element of A intersection B. So these are the elements of A. This is set A. Don't forget, guys, we use uppercase to denote set, and we use lowercase to represent the elements. So B also, we have B 4 to 9 inclusive. So then the intersection means that what is common to both. Okay, for example, you see, let me just take this. Now, if you look at this now, for A and B, I have 4 here, and 4 is here too. Okay, I have 5 here. Then I also have 5 set A. So I have 6 in set B. So I also have 6 in set A. So what is common to set A and B is what? 4, 5, 6. So that's what is common. So that will be the A intersection B. So don't forget that, guys. So disjoint. Disjoint sets are two or more sets that have no element in common. Therefore, the intersection is an empty set. Okay, for example, consider this set A. If set A is all 3D shape with a curved surface. Okay, I hope you know what curved surface are, guys. Okay, and B all polyhedron. Okay, so now don't forget that all surface like this. This is like a circle here, circle. So you have a curved surface here. Okay, cross sections. So the cross sections here are curved surfaces. Okay, then so these are polyhedrons. Okay, and B polyhedrons is this a polyhedron because formed by flat plane shapes. Okay, so we have pyramid and prisms. Okay, so now there is nothing common. This edition said because they have nothing in common. Okay, so these polyhedrons, these are just different from this form. So when you have flat surface cross sections, it's different from when you have curved cross sections. So the cross sections we have in this place, the cross sections are curved surface, and the cross sections here are flat surface. For example, this is a square base pyramid, and it is also a square base prism, or you can that is a cube, and this is 1, 2, 3, 4, 5, 6. So this is hexagonal base prism. Okay, so disjoint, so that will be empty. So guys, don't forget this is empty. You don't write 0. Nothing common does not mean that you write 0. It's not 0 because 0 can be a set. That's a unit set. So it's disjoint that is empty. So this is the symbol we use. Okay. Now let's take a look at this problem. So if universal set is student in the school orchestra, P is the student who play piano, and V student who play violin, and W student who play wind instrument. Don't forget that we use uppercase for sets, we use lowercase for the elements. Okay, it's just that in this type of illustration, this is more of descriptive kind of set. Okay, so the facts we have here: V intersection W. So V intersection W implies that student who play violin intersection student who play wind instrument is empty. Okay, then this is cat. It's Sylvan. Okay, I think it's Sylvan. Guys, you can just care little about this. So this Sylvan. Okay, so Sylvan belongs to V intersection P. So is this Sylvan guys here? This is a cool guy here. I want to know, is this Sylvan? This Richard guy. Okay, and Richard does not belong to P in union W. Okay, don't forget that Sylvan belongs to student who plays violin and because intersection means and piano. And this one says that Richard does not belong to students um that plays piano and wind instruments. Okay, so interpret the information above to determine whether each claim below is true or false. So Richard is not in the school orchestra. So guys, if you say Richard is not in the school orchestra, and this one says Richard does not belong to P Union W. Okay, so I piano and wind instrument, but violin is also there. Okay, so because orchestra is everything all together, piano, violin, and wind instrument, I believe. So when you say that Richard is not in the school orchestra, so this is it now. That is false, because this one says that Richard is not in, or probably Richard does not play both does not is not in piano, or student that play piano and wind instrument, but this Richard play guitar, so so definitely in school orchestra. So when you say that Richard is not in school orchestra, that should be false, right? Correct. So false. Next question. Interpret the following information. Okay, Siobhan plays both violin and piano. Okay, so if Siobhan play both violin and piano, violin is V and piano is P. I'm going to use both. Okay, and both and takes go for intersection. But when you use either or, that uses union. So this says that Siobhan play both violin and piano, and this is it here. So and this is it. That is correct here. That is Siobhan belongs to group of students that play both violin and piano. So that is true. Correct. So let's go to the next question. Richard play an instrument that is not piano or wind instrument. So when you say that Richard plays an instrument that is not piano or wind instrument, so meaning that piano and wind instrument will be empty sets. So and that's what we have here. So but this is not piano, because we say that piano, this is a piano and wind instrument, so this should be P intersection, okay, W, but this is wrong, so this is not the true representation. And Richard, so but this is Richard is does not play P W, and P is piano and W is wind instrument. So Richard plays an instrument that is not piano or wind instrument. So this is it, piano or wind instrument. So don't forget, or that is not or. Okay, so is that true or false? True, guys. So you want to check. So piano, Richard plays an instrument that is not piano or wind instrument. So piano or wind instrument. So that's it, piano and wind. So this or, so use either or. This is it, you, and not Richard not. This belongs to, does not belong to, just cancel it. So that's cool. True. So next question now. Okay, we cannot tell whether Siobhan plays a wind instrument. So we cannot tell whether okay, if we're going by the diagram, this is a wind instrument, I believe, but that's not what we are talking about here. So because we have the fact here anyway, you are not to look at this picture, guys. Okay, so we cannot tell whether Siobhan play a wind instrument. So this Siobhan here, okay, so we cannot tell. This is only one that, this is the only fact that talks about Siobhan. So I'm less concerned about Richard and this first information there. So this one says that Siobhan belongs to violin intersection. So that is both violin and piano. So violin and piano. So so violin and piano are they guys, wind instrument. That's the problem, guys, because I don't even know what is wind instrument, for God's sake. So it's violin and piano, wind instrument, violin and piano, so wind instrument. So definitely, so that we cannot tell, because this one says that Siobhan belongs to this intersection. So we cannot tell. Yeah, I believe we cannot really tell, because this is not wind instrument. So you can just say, what? I'm still a little bit confused, but let's get it right. We cannot tell whether Siobhan plays a wind instrument. But this one is specific. This one here is specific. See that Siobhan belongs to this violin and piano. So we can, you should be able to tell, because if the fact is clear that this is violin and piano, so it is clear that this is Siobhan belongs to this group of students that play both piano and violin. Okay, so both piano and violin. So how do you mean by we cannot tell? So we can tell, guys. Oh, we cannot tell. Yes, correct. So because wind instruments. Thank you about that. So let's just take that again. So I think we are okay, we are through with this. Okay, so we cannot tell whether someone plays a wind instrument because the violin and piano, is that a wind instrument? Okay, so that's it. So next question now. No student play both violin and the wind instrument. No students play both violin and wind instrument. Is that true? Because we have no student play both violin and wind instrument. So do you have violin and wind? VW? There's not like VW. Yeah, there is. Say VW is empty. So if violin intersection wind is empty, so meaning that no student play. So that is true. Okay. So this stage I think we can go either at the end of let's just quickly run through set relationship now. So the complement of a set is all of the elements in the universal set but not in the set of the interest rather. So our Venn diagram are useful too. So at this time, at this stage now, I think we can go ahead and solve the problem we have here. So, but let me quickly give you run through this before we go to the second stage of this tutorial section. Before I teach you how to use set notation to describe region represented in Venn diagram. So, but let's quickly run through this now. So now A only. If I click this, then it's going to shade A. Okay, so that is A. So set A, all elements in A. So the shaded region will just be this part. But I'm going to use a good concept. I'm going to show you a very wonderful concept how I come about this. Okay, what about if we have not A? So A intercept means not A. So not A means that I don't want all the region of A. So that will just be B only. So this A prime is B only. So it will be this white portion B only. So let's click. So you can see is this peak. So because this not A means B only, so B only is this guys, I'm bad in color. What color is this, guys? I care little about this. So but this is the color. You can see my cursor, guys. Then next, A union B. A union B means that A and B all together. So is this two circle, the two subsets. So everything here, that is A union B. A with this all this shaded region. What about A union B complement? A union B complement means I don't want everything in this circle, so that will be outside the circle. So that's that, and that's it. Okay, what about B only? B only will be I don't want B, so that will be A only. So B will be A only, just like we have that. So don't mind me, what am I saying, guys? B is B. This is B here, guys. I'm not, so B, so just shade B. I'm just too playful, guys. Then B complement now. So B complement means that I don't want this shaded part, I don't want this B, so it will be this white portion, that will be A only. So B complement will be A only, so this place. Then A intersection B means that what is common to A and B, so it will be this region, what is common to A and B. So let's check. And finally, A intersection B complement. So this one, I want the complement of it, so that will be the white region, everything outside inclusive, everything. So and that's that. So now, guys, let's go ahead with the last stage of our stuff. I will not be careful with this one here. But let me just quickly solve this. I think it's a good one for us to learn. Arrange the word, symbols, and images into the correct rows. Okay, we have union. So union, so just take this is union. Union goes up there because union should be U. So this should go up there. And union take the word or. So you work with this. And when we have union, we have everything. So everything should go there. So hope you understand union now. So union, we use U, either or, then everything in the circle. Intersection, take this symbol like N, but intersection you take and, not this. So intersection take and, so don't forget and it will be what is common to A and B, so this region. And finally, complement means not A, so not. So and that will be B only. So let's check, guys. Are we correct? Check, guys. Correct. Well done, guys. Okay, so I think I will not really be careful to waste my time with this. Okay, I'm going to solve this type of problem in another tutorial, guys. I can complete that, guys. Let me just do that. I think I can gain the time. Let's just do that. Venn diagram can also show the number of elements in sets. Okay, so let's take a look at this application. There are 30 students in a class, so the implication is that the universal set is 30. So 13 have pet dog. Okay, so everything here in dog is 13. 11 have pet cat and so on. Guys, don't let me waste my time. So 30 is the universal set. So everything all together is 30. Okay, so 13 pet dog. So um guys, so dog all together here is 13. Okay, and because if it has to be only will just be this shaded region. Okay, and 6 are both. So 6 both means that I'm going to write 6 in here. Okay, and label each. So let's just go ahead and do that. So we have, that's the label. So now because for cat is 11 altogether, so I can't have 11 here, so cat only will be 5, because when you sum everything inside the cat, it should give you 11. So what I did here is that I put 11 here before, since I have 6 common, so just 11 take away 6, then you have 5. I'm going to do the same thing for 13. So 13 take away 6, you have 7. So dog only will be 7, cat only will be 5, dog and cat will be 6. Okay, so the question now says to find the number of people with neither cat nor dog. So neither cat nor dog means that what should be outside this circle. So what I'm going to do is that I'm going to add 5 plus 6 plus 7. Then I'll take it away from universal set. Then I'll get the answer outside. So that will be not 12. So the 12 will be outside here. So that's that, guys. So hope you enjoyed the application. So let's go ahead with the stage 2. So I will teach you a very wonderful concept to describing region represented in a Venn diagram using set notation. So let's go ahead and solve that. So at this point, guys, because of our time, I need to quickly launch my electronic board. So let me just pause the video. Okay, guys, so let's take a look at the following question. Okay, now this is we should share the following region. So before to solve this type of problem, guys, this is the concept. So the first thing is that just go ahead and label each region. So I want to label outside 1, then I'll label A only 2, then I'll label the intersection 3, I'll label B only 4. So I have 4 regions altogether. So and this region is applicable to all here. So let me just go ahead and do the same for all, because I want to solve all the questions. I may not solve all the questions. I will just be selective and just depending on our time. So but the same concept works, guys, and because of our time, I want to try and take a look at as many problems as possible. So guys, so you may need to complete the remaining one. Okay. So I will not be careful to do the same for all, but just go ahead with the same level, guys. And when you want to solve any problem involving shading and region represented by giving set notation, you need not to label 1 2 3 4. You can just take any random label. You can label 5 6 7 8. You can label 2 5 10. But I just it's relative, guys. But I just choose this number. Okay, so now the first thing is to write your A. So A. So what are the elements in set A? So set A is the that is don't mind me, this is meant to be brace bracket, but never mind. So set A, this is a circle, this is 1. So what is inside A? That is 2 and 3. So A, I have 2 comma 3. And guys, because I want to try to solve all the let's just do that. Okay, set A, then let's just do this. A, then go for A complement straight, then I'll go for B, then B complement, then because I think some question has to do with complement here. So A, then A complement. A complement means that not in A circle, so I don't want 2 and 3, so I can go for the remaining number, that is 1 and 4, 1 comma 4. And also the same thing is applicable to B now. So for B, just go to B circle. What do you have in there? So B, I have 3 comma 4, 3 comma 4. Guys, this thing is not so fast, guys. Okay, then I will also go for B complement now. So B complement is that what is not inside B circle. Guys, why am I saying B circle? Guys, this is actually, we call it subsets. Okay, because you have 2 circle here, the first subsets. Okay, so we have 2 here. Okay, so don't forget. So B circle now, so I don't want everything inside circle of B, so that'll be 1 and 2. 1 and 2, guys, or 1 comma 2. So 1 comma 2. Okay, and so with this information, I can solve any given problem, and you're going to appreciate this better when I have three subsets. Because three subsets will be quite taxing. Okay, so with this diagram, some of you probably will be able to even indicate the region without this, but this concept you appreciate is much better when we have three subsets or more than that. Okay, so now I want A complement union B complement. So what is complement of A? So I want to compare complement of A and B. So why did I do this, guys? Did I just let me just change my um let me just change the color. Oh, guys, I'm going to waste time if I did do that, but I can do that, guys. Let's just do that. Let's just work with blue. Okay, so now I want to compare A complement. This is A complement here, and I want to compare that with B complement. This is B complement here. So, and what operator am I using, guys? Is an operator. So union. So union means that I should take what is A and B. So now all together. So I have 1, 1, 2, 4. So I'm going to shade region 1, region 2, and region 4. Guys, can I use this to shade? Oh, region 1. I've not tried this before. I know it's going to. Don't let me even do that. Let me just go back to my red color. So can I use line to do that? Let me use laser so that it will be blinking. So the implication that the union is the union. I don't want to write everything, guys. So some of you guys are like the union. Union means that what is union is if it is A or B, either A or B is in. So you just write either A or B. So that will be 1. So 1 is both A and B. Then I have 2. Then I have 4. So guys, but I will not be careful to do this next time. I just have to follow the trend. So 1, 2, 4. So that's it. So then that's what I'm going to do now. Let me just go for add point. So you shade 1. So 1 is outside. Don't forget outside. So I'm going to shade the outside region. That is 1. Then I'll shade 2. This is 2. Then I'll shade 4. So the only part unshaded is 3. So that is the solution to the first question. So guys, hope it's clear. So the only unshaded part here is 3. So I can just complete it like that. So that's the solution to this one. So I think I'm good with this shade. I don't need to do too much, guys. I have a lot of questions to solve. Everything is clear already. Okay, so this one says A complement. A complement is 1 and 4. So I'm going to shade region 1 and region 4 because that is A complement. So meaning that the only part that will remain unshaded is so outside is inclusive. So that's why I did that. So that's A complement. Okay, guys, everything is clear. So you don't shade this circle containing 2 and 3. This one says A union B complement. So I need A union B first. A union B is 2, 3, 4. So 2, 3, 4. The only number left is 1. Okay, because 2, 3, 4 complement means not union. So not this. So not is 1. So you just shade outside. And that's all. But that is 1. So it's only 1 that left unshaded. Guys, at this point I think I'm good with this. I don't need to waste my time with this one. A intersection B is this, and B complement is that. So let's just quickly go ahead and import the next question. So let me clear the page now. So let's go ahead and import S2. Guys, if you need to look at that again, please you can pause the video or rewind. That's why this is a video, guys. Just rewind and go through again. So let's take a look at S2. Guys, so this is a good one. So you're going to appreciate this better now because this time around I have 3 subsets. Why is this thing giving me trouble already? Okay, so this one asks me to shade the Venn diagram. So I'm to shade also. So guys, the first thing is to label. So I'll start outside 1, 2. Hope my handwriting will not flop this thing. 3, 4, I wouldn't know if I should use different colors, but it's okay. 5, 6, 7, 8. So I have 8 regions altogether. So outside 1, 2, 3, 4, 5, 6, 7, 8. So guys, let's get started now. So guys, I will not be careful to solve as many problems as possible. I'll just show you, then you get it once and for all. Okay, A. So let's define set A first. So what do we have in there for set A? Set A 2, 3, 5, 6. Then I need to be careful. What am I saying? This is 6 here. So because this is 2, 3, 4, 5. A is 2, 3, 4, 5. So don't 2, 3, 4, 5. 2, 3. Oh, it's 3 as in 3. As in 3. 2, 3, 4, 5. 2, 3, 4. Oh my god, this one that is quite slow writing. What am I writing again? 2, 3, 4, 5. That's all, guys. Guys, think I'm not going to observe this brace bracket stuff. Is giving me tough time, guys. So B, no writing on this board, guys. So B, oh my. So B, I have 3, 4, 6, 8. 3, 4, 6, 8. 3, 4, 6, 8. So 3, 4, 6, 8. Don't forget I will need to go for complement. I'll just take a look at the question. If the question does not involve complement, I will not be careful to do that because I need to quickly round up this tutorial section. So C. So guys, before you start solving this kind of problem, just take a look at the question very well and see what is there, because based on what I have here now, there's nothing like A complement, so I don't need to bring out my A complement. But for any reason, if I need A complement, my A complement will be 1, because it will be every other thing outside A. So that will be 1, 7, 6, 8. For B complement, everything outside B, that will be 1, 2, 3, 7. And for C complement, that will be everything outside C, that will be 1, 2, 3, 8. So don't forget that. Okay, so C now, everything inside within C circle, and that is 4, 5, 6, 7. 4, 5, 6, 7. So guys, what is going to happen now? I'll not be careful to write A complement, B complement, and C complement. I'll just discuss and then we'll use it to solve. Okay. So you know what to do again, and I also non-label all this. Just go ahead and do the same thing for the remaining question, but I will try and solve as many problems as possible. Okay, so let's go ahead with the first question. The first question says A intersection C. So I want to compare A and C first, and the operator I'm going to use there is intersection. So this is A here, and this is C here. So that's good. So I want to compare A and C intersection. So mean that I'll first get A intersection C first. So the complement is that what is A intersection complement is that what is not there. So every other thing. So let's go for A intersection C. For that I'm going to can I circle? I will just highlight. Okay. I'll just do something like this because I don't want to be writing. My board is giving me a kind of sign already. So the answer solution for A intersection C is what I'm going to write here now. So A intersection C, meaning that what is in this intersection means that what is common to A and C. So if you look at A and C, 4 is common. So I have 4. And if you look at it again, I have 5 too. So I just have 4 and 5. That is A intersection C. Now, but when you have the complement of A intersection C, and my label is 1 to 8, so meaning that every other number apart from 4 to this, so meaning that this answer here now, the answer of this one now, A intersection B complement, this one here, will be all number from 1 to 8, excluding 4 and 5. So that will be, can I use laser? Don't worry. So that will be 1, 2, 3. So I 4 should not be there because it said so, because I a intersection B complement, so 4 5 omit, then jump to 6 7, then 8. 6 7, then finally 8. So that's the first part of the question. Okay, then next, union B. So I want to compare this one here now. So I want to compare this one here, and the operator I want to use now is union, and with B now. So let me just change the color now, so that you see what I'm doing now. Let's just work with blue. So what am I comparing now? So I'm comparing A union, A intersection C complement, and this is it here. Then union B, and this is B here. So I'm comparing the two rectangular boxes, and comparing with what? Union. Union means either also I should take everything here and here up. So what is, and in either this, or better still in both. So that will be 1 2 3 4 6 and 8. So 1 2 3. So let me just write it down with laser now. So our final solution there is 1 2 3 4 6 7 and 8. So that's the solution. So the elements for the question, it does it. Why am I putting brace brackets? I don't just want to do that, guys. So but if I'm going to solve any question more, I need not to be careful about that. So now this one here, so everything here, this is the solution now. So A intersection B complement union, A intersection C all complement union B, and this is it now. So you just go ahead and shade, you're going to shade. So now 1 2 3 4. So the only region that will left unshaded is 5. So you shade every other thing apart from 5. So guys, this time around, how do I shade, guys? I'm going to shade with this because I don't want 5, so I just go ahead and do that. This is pretty cool, guys. I don't just want 5, so every other thing shade. Don't worry, it's only 5. I don't want 5, so this 4 will be out of the game, out of show. Guys, hope you appreciate this now. So if you want to solve this, you can't just use your discretion. I just have to, this method is very cool and wonderful. So the only region left unshaded is 5, because all the solution is all the number from 1 to 8, I'm excluding 5. So that's solution to question 1. So guys, I'll just solve one more question and you can go ahead and do the same thing for the remaining. Just go ahead and do this. Everything is cool. So let me just go for this last one, question 6. But I have the label already, or better still, can I go? I have the label already, 1 2, but I'll just do it here again. Let me just do it here also, but I'll follow this label so that I can work with this information here. I don't want to rewrite. So 1, then I label this place 2, and this is 3. Guys, the only part on okay, so this is 4, this is 5, this is 6, this is 7, and this is 8. So guys, when you have a lot of questions like this, and so you just use the same label so that you don't start all over again. So I don't need to write A out already, because A is what? 2 3 4 5, and you can see 2 3 4 5. B is what? 3 4 6 8. 3 4 6 8 is correct. And C is what? 4 5 6 7. 4 5 6 7. So and the union complement is outside. That is A union B union C complement will be 1 outside. So let's go ahead and solve this now. So the first one here is I can't even see what is in here. Okay, guys, we're using some operator here. I think I can see something like plus minus. If I'm not, is there something like that? Okay, so which is not common. Let me just put something here. Okay, let's just work with B complement intersection A union C complement. Okay, so what I want to solve is so you first work with what is inside the bracket, A union C, then the complement of A union C. So this is A and this is C. So A union C is what? Let's get A union C first. That will be 2. I will not be careful to write it out. 3, 4, 5, 6, 7. So because the union, I want the union of A and C. So 2, 3, 4, 5, because 5 is common, so you can tick it the same way. You can tick this for 2. So what I have here is 2, 3, 4, 5, 6, 7. So the only element left out there is 1 and 8. 1 and 8. That's the only element left out of the union. And that's what we want here, because I want the complement. So I want the complement. So the complement of A union C is that. So A union C complement, A union C complement is 1, 8. So I'm through with that. So don't forget this first solve what is inside the bracket. Then I now want to compare this now. This is my answer with B complement. Do I have B complement? Guys, this is a big deal. So let me quickly write B complement here. B complement. Okay, guys, don't forget we don't need this information again. Let me just so that we don't get this confused. We are through. We solved this question already. Okay. So now B complement now. B complement means that all number between 1 and all number from 1 to 8 except B. So I will exclude 3, 4, 6, 7. 3, 4, 6, 8. So write the remaining number now. That will be the B complement. That is not B. So not B is 1, 2. So I have 3 in B. I have 4. So then 5 is not in B. Then 7 is not in B. So B complement is 1, 2, 5, 7. Okay. So now I have this now. So I want to compare these two with what? Intersection. Intersection means that what is common to both. And what is common? 1 is common. So the only element common there is 1. So meaning that the intersection of this, so that is 1. So 1 is outside. So the implication is just shade outside. So that's solution to this question. Because 1 is outside, so you just shade outside. So guys, hope everything is clear. So guys, at this point, because of our time, I'm going to stop the video now. And you just take a look at, I can quickly discuss the remaining one with you. To solve this one, let's just take this one to be, let's say this is intersection, for example. So we first go for B intersection A. Then what is not in B intersection, A will be the complement. Then you compare your answer with C complement. So same here, and so on and so forth. So at this stage, guys, I want to call it a day, guys. Hope you enjoyed the tutorial, and I wish you great day ahead, guys. Please do have a great day ahead. Bye, guys. Bye guys. Bye. Take good care of yourself, guys, and be happy always, guys. Bye.